In this video, I'm going to be going through the 2022 preliminary examination. This is the examination that's done at the end of Year 11 or the end of Term 3 of Year 11 for engineering studies. This is a 2-hour exam, and it has a slightly few more questions than a standard preliminary exam, like maybe 1 or 2 extra marks. I'll talk about that now really quickly, and just to say that it's hard to know how many marks to include into a preliminary exam because the questions are easier than the HSC. So where the HSC is 100 marks for 3 hours, and you would think that the obvious thing would be to have 67 or 66 or 67 marks. In this case, I think I have actually gone with 67 marks in the end, but I think we'll end up being 67 marks in the end. But it's just that some of these questions, like what is the value of gravity, is a very, very easy question, and I just noticed that in this printing it hasn't been a superscript. That's disappointing. Well, that brings me to talking about errors. Now, I had 2 separate people proofread this exam, and yet there are still a number of errors. There's one critical error, and everything else I think is pretty reasonable. The biggest problem when writing an exam is having a multiple choice question that doesn't have the correct answer in the multiple choice. As much as I look for it, as much as I try to always check the calculations, unfortunately what will happen sometimes is I'll make a last minute change and I will forget to update the answers or something along those lines. And that has happened here. I'll talk about that when I get to it. There are a couple of other small proofing errors, but they're things like not including, say, kilonewtons or having newtons and kilonewtons. Most of the time, students are able to figure out what's going on. Like, for instance, something I really try to look out for now in my exams is A, B, C, D. Sometimes I will have E, F, G, and people get freaked out. They're not sure what to do. For me, that seems fairly obvious. And I will say that as an engineering employee, your bosses will expect you to understand those sorts of questions and be able to, what they call it, ambiguity tolerant. So people who can say, well, clearly there's no EFG in the answer sheet, so it's probably going to be an ABCD, or even if it's ABCB, people, I would expect a intelligent student to understand what's going on, but it's fine to clarify, but just keep in mind that when you're in a professional environment, that if you're asking for clarifications all the time, that's going to make you look less smart than someone who says, I did this and I made this assumption, I made a note of it before it went out. If that's wrong, I can go back and change it. It's funny to know where that balance is of where you making a decision for yourself is a good thing and where you making a decision for yourself is a bad thing. So it's a tough one. The HSC, you're not going to lose any marks by putting up your hand and asking the invigilators to clarify something, especially if it's a paper that's been written by the teacher, like the preliminary or the trial exam. Okay, so with that said, let's get cracking. I'll just quickly point out to say that there's a lot of effort put into this exam. When we look at the trials, there are trials that are made available between schools, and even those exams which are going out to thousands of students, there's still errors in those. So it's the HSC. We do have a higher standard, and having an error in the HSC is a little bit more upsetting. But generally, you have to accept that there's going to be some errors. Okay, so this first question is just taken straight out of the HSC, and it's asking which one shows the bracket in third angle projection. So in Australia, we have we use third angle projection. That means we show the top view on top. So it's going to be A or B, show the top view on top. The front view is shown directly below. That's great. Now the question is which one is front. They've told us that this is front, so A has to be the correct answer there. Not sure what's happened with this font here. Hopefully that was just a scanning thing. Which of the following is most correct? It has sand is coarse aggregate, concrete contains aggregates, cement is a composite material, concrete is a binder used to make cement. I try to focus on which is most correct so that people are aware of the difference between most and not, because I know that when I go through these things quickly, when you see a negation, like let's say which of the following is not correct, that can be confusing, so I try to highlight. It's also to say that whenever we have statements like this, there's always things that are true from a certain point point of view that can be argued. And this is where I try to highlight that even if it doesn't say which of the following is most correct, the point is that you should be giving the answer that is most correct unless it's being negated. Okay, so sand is a fine aggregate. Cement is not a composite. Cement is a ceramic. Concrete is not the binder. Cement is the binder used to make concrete. So concrete containing aggregates, B is correct. What is the correct hierarchy of waste management? So some of you might remember the Jack Johnson song, the 3 R's: reduce, reuse, recycle. So we should be reducing waste in the design stage, then recycling, and then reuse, recycle. There we go. Okay, the next one is engineers typically use what value for gravity? The answer is 9.8. Just checking that against my answers at the same time. In some cases, a unit can measure 2 different properties. Which of the following pairs does not share a unit of measurement? So we have work and energy are both measured in joules. Weight and force are both measured in newtons. Pressure and strength are both measured in pascals. Speed and displacement are both measured, speed is measured in meters per second and displacement is just measured in meters. Which of the following restricts the flow of current in one direction? So that is a diode. Okay, next page. Which of the following stress strain curves represents the toughest material? I don't know if I think I took this from a past HSC question. I made it a little bit clearer I extended this curve out a little bit just to make it really clear that this C has the greatest area under the curve. If we were to color in underneath this line, we'd get a triangle, and the amount of crayon that we'd use to fill in this would be less than we would use in this area here, which has the most. The others are a bit of a muchness. A is clearly the strongest material. It is higher on the vertical axis, and D is clearly the most ductile material. It is the furthest on the x-axis. Okay, so the answer there is C for 7. For 8, a cylinder A has an area of 100 millimeters to the power of 2. Again, I don't know why it didn't do superscript. I definitely on my file, but yeah, what can I do? 100 millimeters to the millimeters squared, and piston B is 500 millimeters squared. So what we can, a terminology that I like is that velocity ratio is equal to big diameter squared divided by little diameter squared. I like that as a good idea of not telling us the mechanical advantage, because mechanical advantage can only be determined, can only be measured, but it can give us a good idea of the velocity ratio. Now, in this case, they haven't given us diameter squared, they've given us areas. And so in that case, the velocity ratio is equal to the big area divided by the little area. In this case, the velocity ratio is 5. So if a 10 Newton force is being applied at X, that means 50 newtons is applied at 8. I try to make that question easy enough. I try to only have one question in the paper that asks you to calculate the area of things. So I try to provide areas so that way I'm not doubling up. A lever pivoting at A has a force balance 100 kilonewtons. So here I mentioned the kilonewtons problem. 100 kilonewtons balanced by a force of F acting at 45 degrees. So this was spotted in the exam that someone noticed that the kilonewton was there. I could appreciate putting up your hand because what it does is it gives you clarification, doesn't cost you anything, but all of the answers here are in kilonewtons. This is in kilonewtons. So there is really, it'd be surprising there's no way that you could get the answer if you'd used 100 newtons because none of the answers here are in newtons. Okay, so here we have F times 424 equal, so what I've written here, rather than writing it out fully as saying the sum of the moments clockwise about A equals 0, what I've instead done is I've just jumped a line and I've simply said that we have anti-clockwise moments have to be balanced by the clockwise moments. So the anti-clockwise moment is F multiplied by this perpendicular distance, which is 424. And that is balanced on the other side by 350 times, so force, I typically write force times distance, so 100 kilonewtons times 350. Now, the key here in this question is finding this 424. How did I find that? Well, because they've told us it's 45 degrees, I know this is the hypotenuse. The hypotenuse is 600. So this is going to be, in this case, 600 cos 45. But I know that cos 45 and sin 45 are both 0.707. So I could just take 600 times 0.707. It's going to be a number less than 600, so it's 424. And when I do this calculation here, I get, so when I have 35 and 3 zeros, so 35,000 divided by 424, I get 82. And that is C. Okay, so the next question is, which statement best defines strength? So strength is... so resistance to wear is hardness, resistance to stress is strength. The textbook, I think, does refer to it as the ability to withstand load. I don't think that's entirely true. It's the ability to withstand load divided by its unit area, which is the definition of stress. Resistance to impact is toughness. Ability to be drawn into wire is ductility. Which SI unit measures power? What is the unit for power? I often do the who's on first, what's on second joke for this one. So what is the unit for power? What is the common electrical safety devices used in residences? Okay, so again, this is one of those ones where we're finding the most correct answer: capacitors, diodes, and fuses. So fuses, yeah, that's correct. Diodes and residual current devices. Fuses are correct. Residual current devices are correct. Capacitors, but diodes and diodes are not really correct. Capacitors, double insulated appliances. Double insulated is kind of, it's not really a device. So that, and here we have circuit breakers and residual current devices. D is the correct answer. So we don't really use fuses as much. Some ovens still have fuses rather than circuit breakers. We still use fuses in cars, although I was talking to an auto electrician. He says pretty much the fuses are never really the problem. And like things very rarely rely on the fuses. Very rarely have to change fuse. But yeah, circuit breakers have replaced fuses, and residual current devices are also known as safety switches. I'll just quickly pause and I'll find you the notes where I talked about that. So in the task that I have called electrical extension, I have RCDs and circuit breakers, and that is a document that I have here where we talk about safety switches, circuit breakers. Here we talk about fuses in cars, fuses in ovens, testing and tagging, and double insulation. Okay, so just trying to get to not have that page highlighted. Which of the following is most correct? Perlite contains ferrite. Ferrite contains austenite. Okay. Perlite does contain ferrite. That's probably the right answer. Ferrite does not contain austenite. Austenite only exists at very high temperatures, and when it cools, it can form ferrite. Cementite only exists at 723 degrees. No, that's not true. Austenite only exists above that temperature. Cementite definitely exists at room temperature. Perlite contains less carbon than cementite. No, that's generally not true. So perlite is made of ferrite and cementite has a higher percentage of carbon. I think it's 0.6% or so carbon. I don't really need to worry about that because it's outside the range of what we use in structural design. So the answer is A. And I'm just checking at the same time. I have my sheet that I'm comparing against. I'll pause. Okay. Now, this problem here is the one that there's a problem. We can see the calculation, and what is the stress due to 7 kilonewtons applied to a rod with a diameter of 11 millimeters? And this is where I'm asking you to calculate millimeters. I'll just zoom in. So what we've said is that area equals pi 11 squared on 4. So I talk about, we should always be calculating area as pi d squared on 4. I say this over and over again. I remember my high school teacher said it over and over again. I didn't listen. But if you plan on working as an engineer, you will never need to use pi r squared, or almost never. You will always be given pipes or rods or whatever the diameter in diameters. We just don't measure radiuses as a rule. And your life will be easier if you just get used to using pi d squared on 4. So what we've been given the diameter of 11, so our area is 94.9. And then if we take 7,000, so then we know stress equals force over area. So we're being asked to calculate stress. So we've got 7,000, which is, we're always converting back to newtons, 7,000 newtons divided by 94.9 is going to give us 74 megapascals. Now, because that answer is not there, what have I done? I have removed that question, except for people who have written on the paper 74 megapascals next to their answer. If they've written 74 megapascals, I have given those students the mark correct, and I've marked it out of the full number of marks. For everyone else, I've just removed the question altogether. Moving on. Okay, so which of the following drawings shows the correct Australian standard representation of a M10 non-structural bolt head? So what have we got here? So to calculate, I don't really like the idea of memorizing these sorts of values, but I have found that just by remembering it as head at 7, nut at 8, I'm able to remember that the bolt head is 70% of the diameter of this diameter here, the what we call the major diameter. And when we're given an M10 bolt, the major diameter is 10 millimeters. So that is either A, so it means we're down to either A or C. The next component is we need to know the distance. What they call here is this is across the corners compared to across the flats. Now, right now, I'm currently looking at a picture of a spanner on my whiteboard, and it's showing the across the flats. So a spanner is the... get a picture. So when we're talking about across the flats, we're talking about this S diameter, the wrench size. Wrench is what they call spanners in America. It's this dimension K. So what we're saying is the dimension E is, so we know the face is 9, right? So if we say the head thickness is 70% of the major diameter, the face side of each side of the hexagon is 90% of the major diameter, and this distance from the corner to corner is 2 times, if we think about this as being made up of equilateral triangles, it's 2 triangles, so it's going to be 1.8 times the major diameter. This distance here, K, which we call across the flats, is the size that we need when we're talking about spanners, and we can see the spanner here, this is imperial, but you get the idea. That is 1.6 times the major diameter. I always think, because I multiply everything by 10, I think of, there's a movie 16 Candles. I think that, when Netflix does the gender-swapped remake, they'll have Molly Ringwald's son, and they'll call that 16 spanners. Okay, so... so this here is across, from corner to corner, so that is 18 versus 7, which is because it's a bolt head. If it was a nut, it would be 8. So I generally, I don't like the idea of memorization, but this is a past HSC question. I've seen it recently, and I need you to be prepared for it, and something that I'll find where I talked about that. So in our graphics notes, where I have advanced orthogonal drawing rules, I say here that we can calculate the head thickness. The hex side is 0.9. and then I've provided the relevant Australian standards here. And then if we go back, I have drawing questions that have assessed this previously here. So these sorts of things. So that's where we can find that. Okay. So, which of the following is most correct? Cast iron has poor machinability. Cast iron is less ductile than steel. Cast iron has poor vibration dampening. Cast iron has between 2 and 4% carbon. The correct answer is cast iron has between 2 and 4% carbon. Question 17, we have a 50 kilogram block rests on a horizontal surface. When a force of 175 newtons is applied to the block, it's on the verge of sliding. What is the coefficient of friction? So we expect you to know that F equals mu N. We should know that mu, which is the coefficient of friction, is equal to the friction force divided by N, which is the normal reaction. In this case, in year 11, we only really worry about questions that are on flat surfaces, in which case the normal reaction is equal to the weight or mass times gravity. So I should have written that N equals mg, but in this case N equals 500 newtons up, so we can say that it's going to be 175 divided by 500. It has to be a number less than 1. Well, it doesn't have to be a number less than 1. There are some very weird cases that we don't really worry about in the HSC, but for our numbers we're expecting a number less than 1. So I didn't do the calculation here, but I should be checking the answers. It's close enough that I can't estimate it. I do need to calculate it. 18 is A. Okay, so now we'll go to... Oh, sorry, that wasn't 18. 17 was D. 17 was B, sorry. I was looking at the wrong line. 17.35. Okay. The diagram shows a simplified electric scooter. Sorry. Okay, it's just I'm trying to show the calculations that is actually on the screen. Okay, so what I have done here is I have just taken these two were in series. I've just added them together. 2 plus 1 equals 3. So we've now effectively got 3 ohms and 3 ohms. I'm pretty sure this is a past HSC question. So what we've said is that for parallel circuits, 1 over R equals 1 plus 3 plus, 1 over 3 or 1/3 plus 1/3. That gives us 2/3. To find so that's the total resistance of the parallel circuit. If we want to find the total resistance, we invert that. So 1 over R, well, is 2/3. So that means R is, flip that, 3 over 2. 3 over 2 is 1.5 ohms. Once we have 1.5 ohms, we're then going to use Ohm's law. V equals IR, or actually it's more accurately I over VR is Ohm's original law. But most people say V equals IR. It's easier to remember. We say that current equals 18 divided by 1.5 equals 12 amps. And okay, identify the microstructures that best represent work-hardened steel. So work hardening gives us elongated grains. Remember that, we're going to be talking about that in a second. So it's either going to be B or C. With this one here, if we're looking at B, we can see it's fully perlite. And fully perlite means that's 0.83% carbon. So if we want to have less than perlite, so or a hypoeutectoid steel, then we should have some areas that don't have those perlite stripes. So we should have these ferrite grains, and that's 0.3% carbon steel. I do talk about this as the one that you really should be most aware of. This is the one most commonly used. Mild steel is the most commonly used steel. I gave a handout when we talked about ferrous metals, so you should be familiar with that. Okay, combination of logic gates is shown. So inputs A and C carry no charge. A equals 0 and C equals 0. B is set to high, so B equals 1. Again, the invigilators came and asked me just to confirm that that is in fact a typo, and it was, so I apologize. So we've got 0 and 1. This now, I didn't label the gates, but the gates are given in the answer sheet at the back of the paper. So if we go to the last page of the book, we are actually given, so you can look up and, NAND, or, and, or. You don't even have to memorize them. I would say it doesn't hurt, but you don't even have to memorize them. So this here is an OR gate, this is an AND gate, and this is an NOR gate, or N-O-R. So I just treat it as an OR gate, and then I use the not dot to flip it and reverse it. Okay, so I have a NOR gate here. Sorry, OR gate, and on OR gate and OR gate just says, well, are either of them 1? And B is 1, so D is 1, because one person is on the list. We have Alice is not on the list, but Bob is on the list. Don't worry, says Dave, you're both in. Over here, we have an AND gate, and here we have, so Bob is still on the list, but Chris is not on the list, and Eddie, the bouncer, says, no, sorry, can't let you in, both have to be on the list. You know, we're no plus ones. Okay, so they then get to F, and Frankie says D is 1 and E is 0. If Frankie was an OR gate, Frankie would say, sure, it doesn't matter, you can come in. But then the not dot flips it and reverses it and makes it a 0. So we're going to say D equals 1, E equals 0, F equals 0, and that is C. So F equals, 20 equals C. Okay, so just check that we're happy with those answers for everything. Okay. So moving on to, so I have 65 marks here, but there isn't actually 65 marks. I apologize for that typo. I don't think there's 65 marks. We'll have a look. Here is how I mark using the constellation marking. You should have seen that before. Okay, asbestos fibers and good thermal. Okay, so question 21, engineering impacts and innovations. Outline the social. Okay, so outline, what I've been using is cube here. So consider circle. And in this case, I've actually written down what that says. Sketch in general terms indicating main features. That is outline. I will grab that for us. I have that open. Okay, so outline. Sketch in general terms, indicate the main features. Okay, so outline this, and I suggest to you while you're doing practice exams, it's not a bad idea to write that out until you just know them by the initials, SGT, IMF, or something like that. I'm not doing that because I'm not studying for the HSC, but that, I would say it's not a bad recommendation. Okay, so circle the keyword, and then we're underlining a social impact of one material used in the manufacture of brakes. So what would be a problem where, so people talked about, I'm trying to think that there was an example where students talked about a consideration in brakes, and let's say they talked about ABS as an example, right? This is a bad example, a non-example. If you spoke about ABS, automatic braking systems, that I can't give you a mark for that because that is not a material used in the manufacture of brakes. So that's what we're trying to underline. So also you need to talk about a social impact. So if you talked about an environmental impact, well, that is not answering the question. You can't really get full marks. You maybe have a very generous marker, but really you should not be getting full marks if you haven't provided a social impact. Yeah. Okay. So, and if you talked about something that was unrelated to brakes, if you talked about the social impact in the manufacture of material of computers, well, that hasn't answered the question, and potentially could get 0 marks for that. Okay, so I've just written out a couple of, I outlined a couple that we could talk about. So asbestos fibers have good thermal properties. replaced by polyamides or aramids because it causes cancer. Now, that, I mean, I've only taken 2 lines where we've been given plenty of space, but that's a quick outline of what you could talk about. So you could say asbestos, and so asbestos fibers were used because they had good thermal properties. They were replaced by nylon, you could say, instead of polyamides, or Kevlar if you wanted, fibers because they're strong. And they replaced asbestos because it causes cancer. It makes people sick. So cancer is the social impact. The material is asbestos being replaced by polyamides. So that's 3 marks. If you didn't talk about Kevlar, but you really talked about the asbestos fibers in greater detail, if you talked about how those fibers were carcinogenic, I could give you 3 marks for using one thing. Now, I did say one material. If you wrote 3 things and you outlined them, I probably am not going to give you 4 marks, but I might still give you 2 if I'm generous. Okay, ceramic brake pads have excellent performance, and I've just written racing. I've written racing. Would normally write that out. I would say that they have excellent performance, which means they have reduced stopping distances. They can allow racing cars to go faster. This has a social benefit, or racing is a spectator sport that has a social benefit. Or you could talk about that they're quiet and they have, driver and passenger comfort. Also, it's better for the pedestrians. Or you could say that although it has a better performance, it's more expensive. That's more an economic impact. But if you can say that people are less inclined to use these better materials because they're prohibitively expensive or they're more difficult to produce. Lastly, I saw a lot of people talk about cast iron. I paid cast iron if they talked about something like vibration dampening. Some people said steel, and my answer is, well, you can't write steel unless you're telling me where, because theoretically a student who knew nothing and who just came in from, business studies, and they sat down, they did this paper, they might say, well, I know steel is an engineering material, and I might say steel is strong and expect to get a mark. You're not really demonstrating any advanced knowledge of a student who's spent 3 terms learning the subject. Okay, so compared to engineering roles, engineering management roles, I'm going to defer to Copeland on this one. So when we're talking about biomedical scope of the industry, one of the dot points was talking about engineers as managers. I asked people to describe or compare 2 different ways that engineers are managers. Maybe I already had it and I just scrolled past it. I apologize if that was the case. It was. Engineers may be managers in 2 senses of the word. Firstly, they may manage the design process or overseeing the development of a project. So they can coordinate teams and oversee overall development. Secondly, some companies have engineers as managers in terms of managing budgets, hiring staff, that sort of thing. So I was pretty generous, I think, in my marking of this. I was flexible and open. You didn't have to write what Copeland had said here specifically, because that's not what the questions are asking. That said, very few people got 3 marks, despite me feeling as though I was being generous. I have compare. I didn't write down compare. I should have, but I didn't. So compare is show how things are different, or no, that's contrast. Compare, show how things are similar or different. So you might say that although both design managers and business managers are concerned with the budget of their projects, a design manager is considering more things like the designer time and the cost of production, whereas a business manager is focusing more on overheads like insurances, paying for paying the rent, ensuring that HR is in place to prevent litigation, those sorts of things. That's just me coming up with an example, which is different to Copeland, but I didn't require you necessarily to show how things are similar and different in order to get those 3 marks. I was pretty happy if someone identified 2, they got 1 mark, and if they described them with a little bit of detail, I gave them the 3rd mark. So if you just identified 2 engineering managers, if you said there are design managers and site managers, I'd give you 1 mark for that because you've only identified 2 things. If you said that design managers focus on the design of the project and construction managers make sure that the project is built safely and on time, I'd give that 2 marks because you've described both of them. And you probably just need a little bit more where if you need to say something where they're similar or different in order for me to give you that 3rd mark. And that's me feeling as though I'm being fairly generous rather than saying you must show how they're similar and different. Okay. But by all means, I always remain willing to debate people if you feel as though you've been marked unfairly. Describe and evaluate the impacts of one household appliance. Again, right at the start of the year, one of the first bits of homework I got you to do was this task. So history and impact of an engineered product. I asked you to. I changed the wording a little bit just when I said this morning. So I edited this morning. I was using the asterisks rather than bullets, and I made these extension. But I have a video that goes into some detail. The MECLAF textbook talks about household appliances a little bit. One student actually talked about this video, Unusually Smart Looking Men. Basically, I make the argument that in the game theory of life, the iron was a bad thing because it increased the amount of work that everyone had to do because 1 or 2 people wanted to look fancy. But describe and evaluate. So with evaluate, that is a HSC keyword, which I'll get that open for us. And evaluate says, make a judgment based on criteria. Determine the value of. So if you want to evaluate a house, so I will say that overwhelmingly people, household appliance, overwhelmingly people said refrigerators. That's fine. And they said, so refrigerators prevent food spoilage. They prevent people from getting sick. They have a time-saving element. Although they do still run on electricity, which produces greenhouse gases. That's a really good comparison. That's not a comparison. That gives a good outline of those considerations. But for an evaluation, you really need to say at the end, you need to hammer home that this is a net benefit. So you can say in the first line, you don't have to leave us guessing. You don't have to say it at the end. You can say at the start, refrigerators are have a net positive impact as they reduce. You don't even have to say the negative. You just can say they reduce the amount of food spoilage and they save time they reduce the amount of shopping for their users. That to me is probably good enough. You have made a judgment in the first line. You've said that they're a net positive impact. You've said that you've given 2 different ways of elaborating on that. You've said that they reduce food spoiling, and you have said that they have a time-saving component. That's good enough for me. If you didn't give a final evaluation, but you gave a good considering both sides. If you said that, for instance, that they let's say you talked about the environmental impact, but you said that on the benefit so for instance, although they use electricity, they actually reduce the amount of greenhouse gases because we have less food spoilage. And food spoilage results in greenhouse gases. That would be something that, that would be somewhere where it would be enough for me to give you that 3rd mark. I think I gave quite a few 3 marks for that, so that's not as much of a concern as this one where I did give more 2 marks. Okay. Sketch and label the microstructure of quenched 0.6 carbon steel in the circle below. Now, that really should be under cubing. That should actually be an underline, but I wanted to circle it just to really stress the importance of that word. I will say that when I first started marking this, I marked pretty quickly. I missed I had written that line quenched. And it's a very different answer if you don't see the word quenched. So really reading the question is important. And it was only when I looked at the next part of the question where I thought, well, show the resulting structure after being annealing. It's like, why would I be showing the same thing twice? And then I went back and had a look. So what you should be showing is, so you need to sketch and label for 2 marks. That's very, very common. A lot of the time, students miss out on a mark because they forget to label. So for any sort of martensite, so either it's quenched or tempered, doesn't matter. You always just draw a bunch of sticks, and I've labeled it as a sicular. You can say instead needle-like martensite. If you just wrote martensite, I still gave you 2 marks. I might as well find a quiz. So in the topic of hardening and heat treatment, I included pictures of martensite. And then there was a quiz where you had to identify martensite. So I looked at it there. Okay. Heat to describe the process of annealing and the resulting mechanical properties in the circle below. Sketch and label the resulting grain structure. So heat to red hot. Or you could write heat to above 900 degrees, or you could write heat to full austenite, then cool in a furnace. Resulting steel is soft and tough. Now, I've asked for a mechanical property. So saying large equiax grains is technically not right. I think I still paid it because I'm generous and it's only it's only Year 11, it's only prelim. But really, if they're saying mechanical properties, that means things like soft and tough. The idea is that the large equiax grains, I guess, comes up here, though I didn't write large equiax grains. So heat to red hot, yeah, okay, so we had to label. Now, it says here, describe the process of annealing. Now, compared to describe process annealing, I think I had 2 students out of 35 who described process annealing. I gave them 4 marks. I didn't take anything off. Process annealing is an extension thing that is talked about in Copeland. When we look at a normalized steel, so we have normalized steel as small equiax grains. Work hardening gives us elongated grains. And annealed microstructure is large equiax grains. We can see that the area marked as 2 is perlite and the area marked as 1 is ferrite. So there's also, just point out this properties of grain structure video, which does an excellent job of talking about those things. Okay, so compare Tig and Mig Welding. This is stuff that we did in our first exam, so this is pretty old content. Both use inert gas to prevent impurities, but Mig uses continuous wire and Tig requires 2 hands. Alternatively, you could say something like Mig is easier to use and Tig requires more skill and more training. You could say that Tig is more suited to stainless steel and aluminium. That's another good answer. I've only given 2 lines, so I've just written these as like alternatives in brackets rather than filling up a whole bunch of space. Because it's compare, we've talked about, haven't been doing all of my keywords. Describe, we have here, provide characteristics and features. So we're describing the process. The characteristics of that process are heating to red hot, or there's different ways of wording that, and then cooling in a furnace. And then it said, and describe the mechanical properties. So the features are soft and tough. Just remember, when we're talking about strong, we shouldn't really be using the word strong in engineering. We should always be writing, so it has, you shouldn't say it's less strong, you should say it has lower tensile strength, as an example. Okay, explain how electricity can be used to produce the movement of a DC motor. So in this note here on electricity and electronics, I have got 2 videos on DC motors. I think they're both pretty good. And then I have a document on DC motors where it says, I asked as a question, describe how a DC motor works. I've said you can use this definition, or you can use this definition, or at the very least, you can say electricity plus magnets equals movement. I did say don't say that in exams. Now, if you wrote that, I gave you 1 out of 3 marks for writing electricity plus magnets equals movement. Most people actually wrote movement plus magnets equals electricity. I don't know if I can give you a mark for that. I didn't ask about series or shunt or back EMF. Even though I think that is kind of extension, there was a question about back EMF once, more than 10 years ago in a previous syllabus, so it could theoretically come up. Okay, so yeah, you can go and check out those notes for a full definition. But I was I will say I was disappointed. I think that fewer people answered that correctly than I would have expected, especially that I give you that specific question for homework. This was answered pretty well, I think. Okay, so what we have is the Acetabular Cup is used in a hip prosthesis. I had asked people, I'd set in the last 2 weeks while we were doing revision, I had set a biological engineering studies report. It's not accessible, but it's homework. And I asked students, a part of that is talking about I gave a sample report as well so people could look at. And so here we have the Acetabular Cup, and we've said that it's made through investment casting. So what are the 4 stages? So the first thing is we'll take a wax model of the cup and we'll coat it in ceramic. Then we'll pour out the ceramic, or we'll melt it and pour it out. In the third step, we pour ceramic into that void, and then the fourth step, we remove the ceramic. Effectively, I can usually tell if someone's written the word ceramic and the word wax. I'm usually pretty confident they've understood the question. Even though I've drawn a diagram, if you just drew the diagram with a little bit better labeling than what I've done there, that diagram on its own, I'd give that 1 mark. Easy. A little bit of description, or I thought this was sort of the fewest words without even the description. I would still give these words 2 marks, but I just provide a space just in case people wanted to give it. Now, this is the other one that I feel bad about in my paper. For the same hip prosthesis, the cup lining has been made of a thermo-softening polymer. Justify the suitable material and manufacturing of the cup lining. I changed my mind midway. Normally I show the stem up top. I removed the stem, and I was going to have the cup lining. I only did half the changes, and I'm sorry about that. That said, most people looked at this picture and they saw the word thermo-softening polymer, and they gave me the answer that I've written here. There was, I think, 1, maybe 2 students who described a process. Like, if someone said the cup is made of titanium and it's made through investment casting, I gave that 4 marks. Even though they didn't justify it. I don't want to debate with people, so I thought, well, okay, they've answered the question that I've asked. Support an argument with a conclusion is justify. So when we're talking about justify, we want to say why we use it. So for 2 marks, for 1 mark, you just need to name a thermo-softening polymer. I'm very generous there. Some people wrote polystyrene. I don't think polystyrene is suitable, but you know what? I still awarded polystyrene. Most people, I don't think anyone wrote a method other than injection molding. I say that if in doubt, always give injection molding for, the answer is injection molding. If you'd read the report that I gave, the sample report, or if you had written your own report, you would know that it's ultra high molecular weight polyethylene, or I've written molecular density. I think they're the same thing. Is injected into is injection molded. Why do we use injection molding? Because it's very efficient. It's a very accurate process. So that's what I've written there. Like I said, if you wrote titanium, you almost certainly got the 4 marks because I made a mistake by not having the lining. Hopefully, when I put up a version of this paper on for future students, that will be correctly written in there. So this is actually why I like to record these videos before the exam, because I actually spot the errors when I do the videos before the exam, even though I got 2 different people to proofread this exam. Okay, a copper wire is, straight away I can see this as an E equals flea question, right? So a copper wire is 200 millimeters in length, has a cross-sectional area of 0.5 millimeters, and a Young's modulus for copper is 111 gigapascals. Now, I've written a note there to say that 111 gigapascals is the same as 111 times 10 to the 3, or 111,000 megapascals. You should know that conversion. It's in the very first pages of the Copeland textbook. The next thing is I've written E equals flea. I expect people to know that E equals flea. And I've then just rearranged it to say we're calculating the tensile force. So we're saying F equals EL. Substituting the values. You'll notice that I've given you the area. I try to only make you calculate the area once, which we've already done. So we've got 0.1 times 11 times 10 to the 3 times 0.5 divided by 200 equals 27.75. I think that was answered pretty well. My recollection is that was answered well. Okay, calculate the strain on the wire. So strain is also on the formula sheet. I guess I might as well show you the formula sheet again. It's literally there. Strain equals extension over length. Now, at uni, I wrote delta L over original length, so the change in length over the original length. I think that's slightly better, but you don't get any nice flea equations if you write that. So I've written both. So the extension is 0.1 millimeters. The original length is 200, so the answer is 0.0005. Now, if you wrote it as some sort of percentage, that's fine, but I think most people wrote it wrong even when they wrote it as a percentage. So, yeah, and they didn't show any working out. Okay. The lever system shown is able to balance a load of 350 and an effort of 150. The biggest problem is that people mixed up the load and effort. A trickier question, if I really wanted to test people, what I might say is a second order lever is shown, and a second order lever always has a mechanical advantage greater than 1. I felt that by actually labeling in the question a load of 350 and an effort of 150, I was helping people, and that was making it less tricky. But I think I gave you 2 out of 3 if you got the thing wrong. Okay, so moving on. So mechanical advantage equals load over effort. Most people remember that. Looks like the word male. That's 233. Velocity ratio is slightly higher. Now, the thing that most people, a lot of people do, I used to make this mistake as well, and I'm sure I probably will at some point make this mistake again, is they don't add the 600 plus 300. I'm like, yeah, that's a trick that gets people. So you notice that the velocity ratio is slightly higher. I made sure that when I made this question that the velocity ratio needs to be slightly higher. The efficiency equals mechanical advantage divided by velocity ratio, which is 85 and rounding up to 86%. Yeah, okay. Next question. So here we have the construction of an arch bridge. The arch was supported at pin R and a cable F shown to scale below. So to do this question, what are we going to do? Okay, so the first way you can do this question is I just drew 2 pictures. You find the point of concurrency. So the first thing you do is you extend this line here. And then so we've got 3 forces in this diagram. So straight away, people who know how to use the 3-force method be like rubbing their hands together saying, hey, here's the payoff for learning the 3-force method. So we've got the vertical force, we've got F at some angle, and we're going to find where they meet. Okay, so then we know the point of concurrency. I didn't write here my usual OMG, POC, oh my God, point of concurrency. But what we've then done is, once we know that point, we can then join the line between the point of concurrency and R, and that gives us this angle. Once you know that angle, you can then just draw it to scale. You can do, some people use the sine rule, not many people. I didn't use the sine rule here. I figure if you're going to do that, you might as well just draw it to scale. This is when I just looked at it to scale, I could see, well, okay, this is going downish, this is going down, so this needs to be going up. They're all going clockwise, therefore it's a closed and equilibrium 3-force diagram, and I just measured it. So I just said, okay, well, if that's 22 millimeters and that's 36 millimeters, if this is 100 newtons, I just did a simple similar triangle and was able to find it quite quickly. And you get 7 marks for those 2 triangles really quickly. Now, I took this question from another person's paper, and the thing that I'll notice is that 10,000 tons is huge. 10,000 tons is 100 times 10 to the 6 newtons, which is a bit clunky, but I just found that that was the way that I was writing the fewest zeros, is 100 times 10 to the 6 zeros. Okay, now, in case you didn't want to use the 3/4 method, I've drawn another method for you here. And what I've said is the sum of the moments about R equals 0, and I'm taking clockwise as positive. I've got the reaction at R multiplied by 0. I'm ignoring the reaction at R by taking moments about R. The perpendicular distance is 0, therefore we can ignore it. Okay, so then I have a clockwise moment, which is 100 times 10 to the 6 newtons, and it is 30 millimeters away. I did not draw this as 30 millimeters away, but this distance here, the width of this rectangle is 30 millimeters. I should have labeled that somewhere in the diagram. I didn't. Sorry. Okay, and then the perpendicular distance to F, you can see here I've drawn here, is D. So I've said that going anti-clockwise, we've got F. Now I've assumed anti-clockwise because this arrow relative to R is going anti-clockwise. So it's minus F times D. So when we bring F over into this side, it becomes positive. We said that D is 18, so 3,000 times 10 to the 6, which is what we get there, divided by 18 is 1.6, pretty close to my 164. Really, if you wrote anything between, say, 150 and, what am I willing to go up to? 180? Yeah, I think I'd give that as correct. Yeah, I don't think there was an issue about rounding, but if I did, by all means, come and let me know. Okay, so determine the force at pin R. Now, this part here, you don't need to write. I just wrote that to make my working out clear. You can just, once you've calculated FH and FV, that's more than sufficient detail. To be honest, even if you just drew this triangle, that would be as sufficient that you could then just, you're more likely to get things correct. I mean, it's 4 marks, so, and I think it's deservedly 4 marks. I didn't choose the number of marks, like I said, I just copied, but I think it should be, in fact, 4 marks. And so what we've said is that what we first need to do is break up this F that we've calculated and need to break it up into units. Now, if you have a carried error, I may not have, I mark very quickly, and because it's not the HSC where I only get one shot, I just mark quickly, and I expect people to come and bring up errors if they find it. That said, I gave a lot of people 0 because they just simply didn't attempt this question at all. I would say that if you're getting 0 at this point, if you're not making any attempt at this question, well, at this point you've got to consider whether or not you want to really stick with engineering, because there is going to be a lot of questions like this in the next term, and that's going to continue with our mid-semester review is going to be all mathematics, and in the HSC there's going to be a lot of mathematics. So I won't go into too much more detail on this here. The working out is there. But yeah, what we're doing is we're finding the F and breaking it up. If you had a carried error, you need to let me know. I probably have given you the marks anyway, but just in case you might want to check it. I go through every paper with every student, so there's a good opportunity for you to mention it to me. Once you've found those vertical components of FV, you are then finding the vertical reaction of at R, and we're finding the horizontal reaction at R. That's really easy. There's only one thing to compare. I always like to draw these little diagrams. I find that's pretty easy. Once you have RV, which is going up, and once you have RH, which is going sideways, then I can use Pythagoras' theorem to calculate R. They didn't ask us to find the angle, which was pretty generous, even for 4 marks, I think still. I think that was pretty hard. So, well, there's a lot going on there. And, the carried error. So, next question, I asked people to dimension. I think you're very unlikely to get a question like this in the HSC. It's possible, but very, very unlikely. Instead, you're going to get piecemeal questions. I have already shown where we've had questions on dimensioning before. And I should point out this is actually from a HSC question. So maybe I'll get that HSC question. So in this video here, I've gone through past HSC questions, and I went through these with the class and talked about different dimensioning standards. And then I'm pretty sure I went through last year's HSC where we saw this question, which we just talked about, and this question here, where different ways of dimensioning. Because of the way that I dimensioned the sample, I added this 55 here because I wanted to show a very commonly incorrect way of dimensioning on this side. So we should know that we need to dimension either above the line or to the left of the line, just like Beyonce. So what that meant is that it was harder for you to have a good place for this radius to come out. I didn't really mind so much where you put the radius. What you need to do is you need to dimension above the line for 1 mark, to the left of the line for 1 mark. You need to have the diameter rather than the radius, and your arrows was the 4th mark. If you feel as though you hadn't got correct marks, please come and see me. I'm more than happy to discuss it with you. And I think we're on our last question. So again, I took this from someone else's paper. 6 marks. Now, I don't really like taking dimensions off the drawing. I kind of feel as though that adds a lot of time, a lot of stress. What I've done here is I have drawn the dimensions. You can see where I've changed my mind about the 39 and the 6. These days are probably like, if I was doing this now, looking at it, I probably should have written the 39 here. But there's no rules when we're talking about dimensioning orthogonal drawing. Sorry, isometric drawings. Okay. So you can see where I've got those dimensions from. I didn't really care if you used the dimensions that much. It needed to be close. So I'll talk about, I had a 6 mark marking scale, which, here I go, I've written down here. So I'll just show you the one in red is me drawing it. I spent about 10 minutes drawing that one. I actually used a ruler. I used the side of my page as my T-square, and drew lines across the page, 28 millimeters apart, parallel, and that was my height. I just drew a line somewhere and then went across 39 millimeters, and then I gave myself a 30 millimeter gap, drew another line, and then went across 48 millimeters and then down. And then I did measure that this was 7 and 7 on both sides. Once I drew the 7, I drew it across. Once I found the center of this thing, I drew that across. This line here and this line here should be parallel, at least close. Okay, then this one here was a drawing that I drew in about somewhere between 1 minute and 2 minutes. I still did construction lines. I still used, there should be a difference between my light and dark lines, but I drew that pretty quickly. Now, it's always easier to draw a drawing when I've already seen the answer, and I can't unsee the answer once I've drawn the answer. But what I'll point out here, so what I'm looking for 6 marks. First of all, there is threaded sections. Now, we've discussed threaded sections, but I'm not marking people down. Now, this came from someone else's paper. They thought it was worthwhile that you should be doing threaded sections at this point. We've talked about threaded sections. I did not remove marks for threaded sections. That said, if you did a threaded section here, I gave you an extra mark. So you could have done one more thing wrong, and I still get full marks. Now, because this thread is shown in hidden detail, there's no good standard for showing thread in hidden detail, so you'll notice that that's done here. In the front view, there is a standard for showing a thread in the front view, so we've done that. Okay, so 1 mark for generally drawing something that looks like this, something that's got rounded tops, a circle in the middle, a flat and 2 sides. Get 1 mark. If you drew something that looked like an L with a little 45-degree stabilizer or a web sort of thing, then you got a mark. Okay, there's a mark for third angle projection, which is that this view is shown it's shown not like the letter L, it's shown as a mirror image of the letter L, and it's shown to the right because we were asked for a right-hand side view, so right side view. So drawing that is what you took. That's worth a whole mark. Showing it needs to be aligned so that the top lines up. Now, if you have a look here at my drawing here, first one, these were pretty well line up, right? There, I drew parallel lines. If you look here, you can see, oh, the top here is a little bit lower, but I've drawn a construction line to show that it was intended to line up. It was clearly drawn freehand. The construction line is what shows that these two shapes line up. And then it's shown correct as the correct orientation. It's not mirrored. Then I have sizes correct. Now, that doesn't mean that sizes need to be totally correct. It just means that this box here should be roughly 30 millimeters by 50 millimeters, right? As long as it's roughly 30 millimeters by 50 millimeters, I'm more than happy with that. And, 30 by 40, and this one should be roughly 30 by 50. What I saw a lot of people do is they drew the diagram a lot longer. Excuse me. I'm not sure where that came from. I will point out it's hard to measure. It's hard to measure these radiuses when they're not given. I will say that it does make life more difficult. And there is skill in being able to measure that off the drawing. If I was being more generous, if I was doing this question again, I would actually at least provide the outside dimensions. I think that is a generous thing to do. So maybe if I was doing this question again, that's what I would do differently. But I gave a mark. I probably reduced the mark scale by 1. Now, if you drew some hidden detail, any hidden detail at all, you got 1 mark. And if you drew all the hidden detail, you got an extra mark, or you could have some missing hidden detail if you drew a center line. Now, I like center lines. I think center lines are important. So if you drew a center line, now you had to show a center line in both views to get that mark. You need to show one here and one here to get that mark. Okay, so that is my my answers for the 2022 preliminary exam. Hopefully you learned something.